Calculating the rate of change. So when we want to find the slope, m, the rate of change, what we have to do is figure out the change in output over the change in input. Sometimes mathematicians use delta, this triangle symbol, to mean the change in y's over the change in x's. We're going to use this formula, our slope formula, y2 minus y1 over x2 minus x1, and that's based on one ordered pair being named x1, y1, and the other one being named x2, y2. So basically we need two ordered pairs, and then we're going to fill into this formula. And that's called the slope of a line. All right, so as we take a look at this one, I have our slope formula here. Remember, m is the slope, or is the rate of change. Here's our slope formula. Another way we can visualize this is rise over run, a comparison of the change in y values over the change in x values. I typically use this whenever I'm trying to get a graph, or I'm using a graph and trying to figure out the slope from the graph. So on this first problem, what we have is the population in a city increased from 23,400 to 27,800 between 2002 and 2006. We want to find the rate of change of the population during this time span. Okay, so let's create two ordered pairs to begin with. I think our input value should be the year, so 2002 is going to correspond with the first population, the 23,400. And a second ordered pair is going to go with 2006 being our year, goes with 27,800. Now I'm going to label these, and I find labeling things helps as we're getting used to filling into a formula. So the first one I'm going to call the sub 1s, and the second one the sub 2s. Now filling into our slope formula, it's up at the top there. That's going to go as y2, 27,800, minus y1, 23,400, over x2, 2006, minus x1, 2002. Doing these calculations, we're going to get 4,400 divided by 4, which reduces down to be 1,100. All right, now if we want to think about our labels a little bit on this, the y values were number of people, right? The population. So the numerator would be population, and the denominator was number of years, right? So in this case, the city is increasing because it's a positive rate of change, a positive slope, by 1,100 people per year. Let's quickly do this next one. The pressure P in pounds per square inch, PSI, on a diver depends on the depth below the surface water, D, in feet. All right, so D is our depth, and P is the pressure. All right, so we're given an equation, P of D equals 14.696 plus 0.434 D. All right, we want to interpret these components. So again, we want to kind of go back to y equals mx plus b and try to identify m, the rate of change, and b, the slope, the y-intercept, or the initial amount. So in our case, because the variable is sitting next to the d, or the variable is sitting next to this number, the 0.434, that's going to correspond with the m in our formula. All right, so m is going to be 0.0434. That's positive, so it's increasing at a constant rate. So for each foot, D changes. So for each foot under the water that this diver goes, the amount of pressure, the output, is going to increase by 0.434 pounds per square inch, because that's the units given to us up here, pounds per square inch. All right, and then the other component going along with this is the 14.696. 14.696 is going to correspond with B. That's going to be the initial or starting amount. Okay, so before you go under the water at all, we automatically, if we're above water, have 14.696 pounds per square inch of pressure on us without any added pressure. Another way to think about this is if you said our depth is 0 feet under the water, you get 14.696 plus 0.434 multiplied by 0. This part goes away because it's multiplied by 0 or makes us 0. So what we're going to be left with, if we're 0 feet below the water, is going to be that initial amount. All right, I hope this helps out as we're trying to understand slope. Get that formula down. It's important.